4 basic SQL operations. Starting from today, and throughout the remaining of the semester, we will practice SQL queries. We will practice a large number of SQL queries. Okay? This module, we practice basic SQL operations. In the next module, we will practice complex SQL operations. Yeah. All right. Today, part A, data retrieval by select statements. So today we only learn one type, select. Yeah. But actually, later you will see most of the time we will spend on this select statement. In our SQL practice, almost 90% of the time we will spend on SQL statements. Because the remaining update, insert, delete, straightforward. Yeah. Not much to learn. Okay, not much to learn. Update, insert, delete. You know, just a few examples. Yeah. We can do all those things, but SQL, select statements, that could be very complicated. The reason data retrieval, different users, they need different data, right? Different part of the data. Yeah. So that could be very complicated. All right. But today, we start with the, fundamentals of select statement. So many concepts we need to learn. All right, so let's start 8.1 basic form of select statement. All right, yeah, okay. So let's look at the format, the syntax format first. All right. Select from where block. So the typical format here, you can see 3 components: select part, from part, and the where part block. Yeah. So let's look at one by one. Yeah. The typical format is like this: select. After that, you need to provide attribute list, a list of attributes in certain order. We know order matters, right? For attributes, order matters. Okay, yeah. From table list. Yeah. You may have more than one tables here. Table list. Yeah. Certain number of tables. But more tables you have, the harder. Yeah. First, we only put one table. That's pretty simple, pretty straightforward. One table. After that, we will consider 2 tables. Yeah. So most of our multiple table select statements, we work on 2 tables. Yeah. Because if more than 2 tables, 3 tables and more, too complicated. Most people will get lost. More than 2 tables, people will get lost. We may have 3 tables, but small number, very small number of examples, practice questions. Yeah. But most of our multi-table select statements, we work on 2 tables. Yeah. All right. In the where condition. Yeah. So we will study in details. Yeah. Projection attributes. This concept, projection. Yeah. Here, this projection, the concept we just use in math, we have projection concept, right? Yeah. Something like, so you have a slant line, you have lights in this direction, we do projection, all right? So then you know, this line segment. That's the projection of that slant line. Yeah, line segment. Yeah, this line segment. Yeah, but in our database queries, we have the similar situations. Yeah, you know, this part corresponding to that part that represent all attributes for one table, for one particular table. But in our select statement, many times we do not need to retrieve all attributes, right? Data for all attributes. Yeah. Most of the time, our users, they're only interested in some of the attributes. Yeah. So we only show those attributes that our users are interested in. So those part of the all attributes, that part corresponding to the projection attributes. Yeah. All right. So that concept we use here. All right. Okay. The select clause specifies the attributes whose values are to be retrieved. Yeah. Yeah. Selected part. Okay. Yeah. Then selection condition in the where clause. Where clause we specify selection condition. Okay. Yeah. All right. So the where clause specifies the Boolean condition that must be true for any tuple. Right? Any selected tuple. Only when the condition is true, we select. Okay. If it's false, we do not select. Okay. Remember, there is a third value. Other than true, false, there is unknown value, right? The unknown value, we do not select. Yeah. Only true, we select. Okay. Yeah. All right. Oh, yeah. Yeah. Okay. Yeah. So here you can see pretty simple. Yeah. So in our first view, the structure is pretty simple, but we need to elaborate. So a lot of details. Yeah. We need to understand. Yeah. All right. Retrieval select statement. Yeah. Result return. So let's look at it. What is the typical format for the return result? Okay. It's a table. Yeah. I described it a little bit last time. It is another table. Okay. Rows, columns, another table. Yeah. And what's the typical structure of that table? Last time I also mentioned that part. The typical structure, multi-set. So I hope you still, remember that multi-set concept. But here I will talk about that another time. Yeah. All right. A multi-set of tuples. Not a set of tuples. Okay. Set and multi-set. The main difference is for multi-set, we allow duplicate tuples. That's the main difference. Duplicate tuples. Okay. Yeah. So you may have multiple rows. They have exactly the same tuple values, including the orders, all the same. We allow that case. The reason is simple, because in our real world applications, we need that kind of result. It's useful. It's quite useful. Yeah. All right. So we will see, more explanation on that. So duplicate tuples can appear more than once. Yeah. So that's the multi-set. Yeah. So you can imagine if you do not allow that, then you have a lot of troubles. If you do not allow duplicate tuples, okay? Yeah. Only enforce set concept, a set of tuples, yeah, then many functionalities. You will see many useful functionalities you cannot use. Yeah. So you will have a lot of troubles. Yeah. All right. Reasons not eliminating duplicate tuples. All right, some reasons. First, the user may want to see duplicate tuples in the result of a query. Yeah. When you work on specific applications, sooner or later, you will have the situation. You need to handle duplicate tuples for your search results. Yeah. So user want to have that kind of results. Yeah. Tuple elimination is an expensive operation. Another reason, yeah, but you know, this, if you need to do that, then even it is relatively expensive, you need to do that, right? Yeah, but here is an expensive operation. Why? Think about how do we remove duplicate eliminations? Yeah, it's a simple problem. You can treat as an array, right? Your table search results, you have a list of rows. You treat that list of rows as a string array. Okay? String arrays. Yeah. Then, in order to remove duplicate couples, you may need to do search, right? Do sorting. Think about that. If you do not do sorting, do you want to, you know, do comparison, all the possible tuple comparisons? That would be too expensive. If you do not do sorting, can you find some way faster? Right? Think about that. But if you want to do sorting, that's very expensive. Especially you have large number of rows. It could be very expensive. Yeah. All right. Yeah. One way to implement it is to sort the tuples first and then eliminate duplicates. Yes. Yeah. But inside DBMS, we know DBMS has its internal implementation. We don't know the detail of that implementation, but we, you know, most likely that implementation will be much faster. Much faster. Okay, yeah, in the DBMS implementation, yeah. So you can imagine the technology like hashing. Think about that, hashing, all right? Yeah. If we use the hashing technology, then we do not need to do sorting, but you need to construct hash table, right? You need to construct hash table, you know, yeah, yeah. So. Here, I like to convey this idea. DBMS may have more efficient algorithm to implement that feature, remove duplicate tuples. Okay, so it will be faster. Yeah. All right. Then for us, in order to remove duplicate tuples, we only need to tell the DBMS. We add the keyword distinct after that select keyword clause. Yeah, for the select clause. Yeah. Distinct. Yeah. One extra keyword, then you will remove all the duplicate tuples. Yeah. Yeah. All right. So then when an aggregate function is applied to tuples, aggregate function, we will learn several aggregate functions. Yeah. But here I do not go there. Yeah. We will have chance later, yeah. Like count count the number of rows, okay? Maximum, minimum. Sum, yeah. So those average, those are the aggregate functions. Yeah. So when you need to apply those aggregate functions, many times we may need to deal with the duplicate tuples. Yeah, that's quite natural. So that's another important reason we need to allow duplicate tuples. Okay, all right, yeah. So 8.2, remove duplicate tuples. Let me show you one simple example. I upload the company database. So now you can download module 4 part A, company.sql. So you can download, install. Then if you want to do practice, you can work on it. Okay, yeah. All right. So 8.2, remove duplicate tuples. Yeah. Let me just show you a simple example. Select distinct syntax. Syntax is very simple. Yeah. Yeah. Select distinct, then column 1, column 2, the number of attributes in your list. Then from table name, yeah, you just do a normal select statement, but you add an extra, that distinct keyword. Then you will remove all the duplicate tuples. That's simple. All right, yeah. So let's look at a simple example here. We use that company example. All right. Look at this example. We do a query on that dependent table. Now, one of several, I remember 6 tables, about 6 tables in that company database. Dependent. In that table, distinct, because if we do not put this keyword distinct, ESSN corresponds to employee social security number, because each employee may have multiple independent, right? Yeah, and sex, yeah, that could be duplicated, right? ESSN could be repeated, sex also could be repeated. Look at that, all right? Yeah. So when we enter this query statement in our SQL window and we run it against our company database, we will see this result, okay? Yeah. But in this result, you can see some duplicate. Yeah. Can you see some duplicate? Yeah. Yeah. Oh, no duplicate. Oh yeah, because remember, we already applied distinct. Yeah, from this result, you cannot see. Yeah. Removed. Yeah. But if you do not put that distinct, yeah, you can see some duplicate tuples. Yeah. Yeah, that's pretty simple. All right. Yeah. Okay. So that's this example. Yeah. Next, 8.3, join 2 tables. This is the hard part. Okay? Yeah. Join 2 tables. But today, we just study the basics. Yeah. Not very complicated. Yeah. But why I say this type of questions could be very complicated, because later when we move to module 5 about complex SQL queries, most of the questions are about this part. Join 2 tables. Okay? Yeah. Because if a single table query, usually not very complicated. Yeah. But for multi-table queries, then it could be very hard. Yeah. All right. Okay. Join two tables. First, let's look at our query question. So here, this is the query question. Retrieve the name and address of all employees who work for the research department. Look at this statement. First, when you understand this statement, you can see we need to use employee table because the name, address, that information is stored in employee table. Second, who work for research department. Yeah, research department. You also need information from the second table, department table. So then you need to join these two tables. There is some correlation between these two tables. All right, so let's look at how to write this select statement. Yeah. All right. Two tables are used. Employee, yeah, sometimes here I put a parenthesis E because sometimes in our select statement, we like to use aliases. Yeah. So here, this is alias. Yeah. Because we need to refer to these tables, but we may not like to type the full table name. We want to make the reference a little short, so many times we use aliases. Yeah. Here, the E and the D, E is the alias for employee, and the D is the alias for the department in this query. All right, yeah. They are related. In which way? Yeah. There should be some direct relationship that exists between these two tables. Otherwise, we cannot establish table join condition. So we need this kind of relationship. Yeah. So what is the relationship? Yeah. Here I do not. I didn't show you the, definition of these two tables. Yeah. So you can look at by yourself. Here I just tell you D dot D number. Yeah. Alias D, that department table, dot. We use dot operator. Yeah. Dot D number, department number in the department table, yeah, equals E dot Dino. Yeah. In the employee table, there is a Dino field. Yeah. We try to use different names for department number column. The reason we try to, avoid confusion. Otherwise, if we can use the same name if you like, right? Yeah. In that way, sometimes you may have confusion. Yeah. So here, we try to avoid confusion. Yeah. All right. Join condition. Now we need to work on the join condition. Yeah. It combines two tuples, one from employee table, another from the department table. Two tuples you put together to get a joint tuple, a new tuple containing both tuples. All right. One from the first table and one from the second, whenever their values are equal. Yeah. So this equal value, when the values equal, so we can make that join operation. Okay. Yeah. All right. So let's look at the solution. This is the SQL statement. Yeah. That is the solution for our top question. Yeah. You can see select F name, L name, address. Yeah. For the requirements, we need to retrieve name and address. Yeah. First name and the last name and address. Yeah. All right. From employee, the first table, comma, and department, second table, two tables separated by comma. Yeah. All right. Some students, when they search the web and working on questions like this, many times when they join two tables, they find the answers from web with inner join, outer join. Yeah, join. Yeah, put that word join. Here you can see we do not have join. Okay, yeah. So actually it's a default case join. Although we can put that join, inner join, and outer join, two different join operations. So yeah, we will see the difference. Yeah. But here we use the default case. Inner join is the default case. Yeah. So we do not need to put that join word there, keyword. Okay, yeah. So that's the most commonly used join case. Yeah. Comma, yeah, that's enough. Okay, to put two tables together. Yeah. Then where clause, two conditions. Two conditions. Yeah. The first one, D name equals single quote research. Single quote research. The string value, single quote. All right, yeah. And yeah. Boolean operation and. All right. D number equal Dino. Yeah. Look at here. Here we do not use the alias, right? We do not use that D dot thing, and we do not use that E dot thing. Yeah. Because the reason is simple, because they have different names, right? Yeah. Because D number only appears once in the whole tuple. No confusion. So we do not have to use that alias, right? So you can just write D number directly. Yeah. Dino, it only appears once in the tuple. There is no confusion. So you do not need to put that alias E dot Dino. Yeah, yeah. Although it's optional, yeah, you can skip. Yeah. But later you will see, even if we do not have to type the aliases, but for better readabilities, most programmers like to put aliases. You know, those fields come from what tables? For better readability, especially when your SQL statement become very complicated. Yeah. So you're willing to type a little more, okay, to get a better readability. Yeah, you will see later, most of the time, we use aliases. Yeah, although we do not have to. Yeah, all right. This one, we have a name for it. D number equals Dino, this condition, we call it join condition. Because we need to, when we apply this condition, we can join two tuples. Yeah, join condition. Then this one, we call selection condition. Yeah, selection condition. Yeah. So, and in order to understand the SQL statement, join, type, select statement better, yeah, so we need to consider the order to apply these two conditions. Which condition we should apply first, right? Yeah, so let's understand that part. Yeah. In the natural order. So we like to understand the internal implementation of table join. Yeah. Internal implementation. In DBMS, how does DBMS implement the table join operation? So we want to understand from there. Yeah. Okay. All right. So the next slide, let's understand table join. Here, we need to use some abstract concept from math, from discrete math. Discrete math, we have this concept. Here, we need to use it here. Okay, yeah, so what's that? Yeah. If more than one table is specified in the from clause, and there is no where clause. All right, so when we understand, we want to do it step by step. The first step, we want to make our situation as simple as possible. How to make our situation simple? Yeah, we ignore where clause, because the where clause relatively more complicated. Yeah, we just take away the where clause. Then let's look at that part. That part easy to understand. So we start from there. After that, then we add a where clause back. After we understand that first part, then we add a where clause back to, you know, get a final understanding. Yeah. All right. Here we use that cross product concept. The cross product concept. Yeah. All possible tuple combinations. What is the cross product in math, in discrete math? Yeah. Cartesian product, another terminology for that. Cartesian product, cross product. All right. Yeah. So people call it in that way. All right. From math, let's review Cartesian product. Okay. Yeah. In set theory, a Cartesian product is a mathematical operation that returns a set from multiple sets. Multiple sets. Here, let us consider two sets. Two sets, and we do Cartesian product to get a new set. Okay, yeah. So the notation is like this. A cross B, all right, Cartesian product, this notation, okay, yeah, equals a tuple, all right. The first element, little a, comes from A set. Second element, little b, comes from second B set. Then put them as a one new element. Define this tuple as one new element. We call it Cartesian product of A set and a B set. That's the math definition. Okay, yeah. Math definition. Here we need to use this concept in our current situation. Yeah. All right. Cardinality, the number of elements in the Cartesian product. Cardinality. Yeah. How to calculate the number of elements in the Cartesian product. We use the vertical bar absolute value. Here the cardinality represent the number of elements in a set. Yeah. All right, so the cardinality of A cross B equals the cardinality of A times cardinality of B. Just multiplication of two cardinalities. Straightforward, pretty simple. Yeah. Total number of elements in our new Cartesian product, A cross B. Yeah. All right. Extend it to database theory. Now we are in the SQL theory. We need to use this concept, but we need to modify it. In our SQL theory, we do not use set in math. we use multi-set concept in math. So we need to make that extension. Yeah. So the first extension should be table. We mean it is a multi-set, not a set. It is a multi-set. Okay. So you need to consider duplicate tuples. Duplicate tuples, you need to count those many times. Do not do any simplification. Okay, yeah. So apply Cartesian product on multi-sets. This time, our Cartesian product is applied on multi-sets with all the possible duplicated tuples. Yeah. So that is the, first part of understanding. We will have much more understanding. Yeah. All right. 8.4, digest table join operation. With that Cartesian product concept, now we can understand better. So we need to digest, because it is probably the hardest part of our SQL queries. So we really need to spend plenty of time for this part. All right. Okay, digest table join operation. All right. When we join two tables, let us slow down that operation. Yeah, bit by bit. Yeah. If we move too fast, we get lost. Okay. So let us move slowly, step by step. Yeah. Try to understand bit by bit. Right. All right. When we join two tables, let us do the first simple step. That is, join two tables with cross product. Cross product. I need to use that one. So here, this concept is useful. Cross product without considering join condition. That would be easier. Yeah. We ignore temporarily the join condition to make our life easier. All right. Yeah. So cross product. So we understand the meaning of that cross product. Okay. Let's look at that. This step always works. Yeah. Don't worry. You get your result. Yeah. Always works, because we later, after we add a join condition, we may get empty result, right? Think about that. None of the tuples satisfy that join, so all the conditions. You may have that situation. That's reasonable. Yeah. But this one, we have non-empty result. Okay. Yeah. Because we work on non-empty tables. Yeah. At the beginning, we work on non-empty tables. Yeah. All right. Let me just use that cross product concept. Suppose we join table A and table B. Okay. In this round, we get that A cross B table. Okay. Yeah. All right. And we know the number of elements in this Cartesian product equals number of elements in A's table times number of elements in B table. That's simple. All right. Yeah. So we have a big table. Yeah. Big table. All right. Apply the join condition. Now on that Cartesian product table, that big table. All right. Yeah. we can treat as a superset containing all the possibilities. Now it's the time to apply the join condition. Okay, so you can eliminate many tuples that cannot be joined. Yep, look at that join condition. Only from our previous example, only when D number equals D no, we select it. Then that part is true, we select it. Otherwise, we don't select it. So you can see this step, we will remove many tuples. Yeah. All right. So use the imaginary tuple variable. Here, I use this concept called a tuple variable. So what is the tuple variable? Imaginary. All right. Yeah. You cannot see it. You just imagine it is a concept. You try to visualize it in your mind. So imaginary tuple variable. Yeah. In my next slide, I would explain this concept, tuple variable concept, in my next slide. All right. Yeah. So use the imaginary tuple variable to go through all the tuples. Yeah. So there is a iterator. Yeah, next slide, we will use this term, iterator. It's just like a for loop, right? For loop, you have a iterator. That variable, you need to do, processing, item by item processing. Yeah. So that is the role of this tuple variable concept. Yeah. We will discuss this concept more in our next slide. All right. Only select those tuples that satisfy the join condition. We can do by using our eyes, okay? Observation, we look at D number value and a D no value. When they are equal, we check it. Selection. Yeah. So that's this step. All right. After that, not done yet, because you have the selection condition part. You need to apply selection condition to eliminate more tuples. All right, more tuples. Yeah. So here, our selection condition, remember, the department name equals research. That's the selection condition. So you look at the department name, that field. If the value equals research, you select it. It's true, you select it. All right, yeah. So on the result table, all right, you make that selection. Yeah. It looks like I missed something. Yeah. Yeah. Well, yeah. Whatever. Yeah. All right. After that, you make that selection. After that, make projection when necessary. Yeah. At the end, because after you eliminate all those tuples not satisfying one of the two conditions, either join condition or selection condition, you cross them out. Then for the remaining tuples, you don't need all the attributes, right? Yeah, you don't want to display all the attributes. You only need to display those attributes that our users need them. In that case, you do the projection. So that's your final result. So this is all the details for a typical table join operation. Yeah. All right. So you get after projection step, you get a final result. Okay. Yeah. All right. Yeah, here on the result table, because after the join condition, you apply select condition on that intermediate result table. Yeah, that is an intermediate, temporary intermediate result table. Okay, so you apply on that. Yeah, so you may not be able to see that. So just imaginary. Okay, some intermediate table. Right? Yeah, otherwise, you may ask, what is the result table? Right? Yeah. So from the above step, you have a temporary result table. Okay? Yeah. All right. Tuple variable. Now let us understand this concept. Tuple variable concept. Okay. All right. Think of an implicit tuple variable. Implicit, yeah. So you may not be able to see it explicitly. All right, yeah. You can only imagine it, yeah. You know, yeah. Or iterator, yeah, just like a for loop, yeah, while loop, just like a loop. Then there is some iterator you need to use to go through all the tuples in the loop. All right, yeah, in the SQL query. Yeah. All right. Looping over each individual tuple in the table. Yeah. The first time you process the first tuple, second time, second tuple, and so on, in that order, in the natural order. Although we know the order is not important, right? In a table, the order is not important. We treat it as a multi-set, so the order is not important. But you need to have a processing order, right? One after another. So just some natural processing order. Yeah. Then evaluating the condition in the where clause. When you work on the current tuple, yeah, because you treat it as a variable, there is a current state, right? Current state of that variable. Okay? Every time your tuple variable takes one particular state, that is the current role. So you look at that particular role, you apply where clause on it. In your where clause, you may have two conditions, join condition and selection condition. All right, yeah. So only those tuples that satisfy the condition are selected. So for your where clause, the Boolean statement evaluated to be true. Yeah. For your where clause, could be a big Boolean statement. Right? Big Boolean statement. So you consider the value of that big Boolean statement. That statement should take the true value. Then you select it. Okay, so that's the typical procedure. Now, when you do imaginary thinking, yeah, so you may need to use this imaginary tuple variable, you know, go through all the rows and apply two conditions, join condition, selection condition. All right, yeah, so that's the typical understanding, yeah, of this operation. Yeah. All right. Then, because so far at this point, our discussion is still very abstract. Yeah. So we use abstract concepts, although I gave you two examples. Yeah, two simple examples. But still, when we understand table join operation, at this point, we use our imagination at this point. Yeah. So in our 8.5, I want to use a concrete example to show you the join details. Yeah. In this way, hopefully you can get a better understanding. Okay, yeah. All right. Illustration using an example. Yeah. All right. Part one. Yeah. So let's look at this. Yeah. The same example. We just learned, but this time I like to use diagrams to show you the table join operation details. Yeah. So visually, so you can see something concrete. Some concrete tables that we just describe it step by step before. Okay, all right, so let's start. Yeah. Before we join, let us list two tables side by side. The first table, employee table, I put a 40 in the parentheses. That means there are 40 employees in this company. 40 records, 40 rows, 40 employees in this employee table. 40, all right, yeah. So the cardinality of this set or multi-set, set or multi-set. Here, we do not have duplicate elements. Yeah. In the employee table, we do not have duplicate tuples. So we can call it a set. Okay, it's legal. Yeah. All right. Second department table, there are 6 departments. Yeah, so I put a 6 in the parentheses. All right. Then, in order to represent tuples in the employees table, I use little s, S1, S2 through S40 for 40 employees. Yeah. To show you how do we do the combination. Yeah. All right. In the department table, I use T1, T2, T3, T4, T5, T6. 6 T tuples, 40 S tuples. Our first step, we combine these two tables using Cartesian product. Yeah. So let's look at the Cartesian product step. All right. Employee cross department. All right. Yeah. You get a big table. Okay. Imaginary big table. All right. Yeah. All right. Okay. Look at the number of rows and the number of columns. Number of rows, 240. Why 240? 40 times 6. The product of two cardinalities. The first cardinality 40, second cardinality 6. Product of these two numbers, you get total number of combined tuples 240. All right. How many columns? Look at the number of columns. Yeah. You need to look at how many columns in employee tables, how many columns in department tables. Then you put them together. That's the total number of columns. That's the addition operation. Okay. So when you look at the number of columns, you do addition operation, not multiplication operation. Okay. All right. Then our representation. Combine the tuples. Here we use S1, T1, the first combined tuple. S1, T2, S1T3, S1 until S1T6. After that, S2T1, S2T2 until S2T6. Then S3T1 through T6, and so on. Last one, S40, T1 through T6, all right, 240. That's all the possible combined tuples. That's the Cartesian product. That's the meaning of the Cartesian product. All right, that is our first step. Not done yet. We need to do more screening or filtering. Yeah, so you can treat as filtering, yeah, one by one until we get the required result. All right. S1, there are 10 columns. Yeah. So we count. Employee table, there are 10 columns. All right. Second table, T1, 4 columns. So for the combined tuple, we have 14 columns. All right. Now we need to do selection and projection. Yeah. Selection and projection to get our final result. Yeah. All right. So next slide. Yeah. So when we start, we have that big 240 tuples table, and each tuple there are 14 columns. That's our starting point of part 2. Yeah. Now we need to apply join condition first, then selection condition second. After that, projection third. After those 3 steps, we will get our final result. Yeah. So let's look at step by step. First, yeah, when we start, we have 240, 14 tuples. Okay, 14 component tuples. Yeah. All right, yeah, 14 component tuples. All right. Then we apply join condition. Deno equals D number. Yeah. We just compare those 2 columns. If Deno equals D number, we select it. Otherwise, we do not select. Okay, yeah. So after this step, join condition, we get 40 tuples, 14 tuples. All right, yeah. Because 40 employees, look at that. Each employee, there is a department number, right? Yeah. So that department number, Deno, you connect to that department tuple. Yeah. So each employee, you join it with one department, because one employee can only belong to one department, right? Yeah. So that's why you have 40 tuples after the join condition. Right. Then we apply selection condition, second step. Yeah. So for the second step, we check the value of D name, department name, D name, yeah, in the department table, that part. So D name equals research. Yeah. Only the department name equals research, we select it. Okay, yeah. So that's the selection condition. After we do the screening, filter out, by applying this condition, we have 14 tuples, because we only find 4 tuples that satisfy this condition. Yeah, all right. But each one is a 14 tuple, 14 columns. And we do not need all 14 columns, right? So we do projection. The last step, we only need 3 columns from the 14. So we do projection operation. Yeah. So then our final result, after we do the projection, we have 3 tuples as the final result. Okay, yeah, all right. So then that's the final result. Look at that. F name, L name, address under the column names, 3 column names, we have 4 rows. All right, so 4 employees that satisfy the given condition. How about that? Yeah. So this is a complete understanding of the table join operation. Yeah. So I hope you understand all the details. Yeah. Get used to it. Okay. So at the beginning, when you study, so you can slow down. Yeah. Try your best to understand all the details. Yeah. After that, when you get used to it, later, when you have many such questions, table join questions, then you will get used to, how to use your logical reasoning to get the final result. All right, yeah. But the good thing is, remember, yeah, because most of the students, so they may write the answers, just use the logical reasoning, yeah, because we have that company database. You have the real database there, right? So you can do verification. Yeah. If you want to make sure your SQL statement is correct, you can enter your select statement into the SQL command area in our PHP MyAdmin, that application, web application, and click Go button, just look at the result. And then look at if you have any errors. Sometimes you may have some errors. Yeah. So you try to do debugging, all right, try to fix until you get some reasonable results. Yeah. For the results, use your eyes to check if all the conditions are satisfied. Okay, yeah, because this database is not very big. Using your eyes by observation, yeah, many times you can figure out the answers. So in that way, yeah, you have a chance to fix any possible error. Okay, all right, yeah. So that's pretty much I like to cover today. Yeah. So, and yeah, so after that, yeah, we started module 4, but I need to give you a homework assignment covering first 3 modules. So module 4 and 5, yeah, actually 6. So I plan to spread. Yeah. Let me tell you my remaining, my plan remaining. I may need to adjust my plan a little bit. Yeah, because the hardest part of this course, that's the SQL query part. Yeah. So I like to let you practice as much as possible. So starting from today and throughout the remaining of the semester, we try our best to do practice on SQL queries. Okay, yeah. So then I plan to organize the remaining of the semesters, let's say in 6 modules. So at this point, so let us say 6 modules. All right, and I want to spread SQL queries in all these 3 modules, remaining 3 modules, number 4, number 5, number 6. But in the middle, I also talk about other theoretical concepts. In that way, I stretch the period a little longer to give you a chance to do more practice on SQL queries. Try to get more experience on SQL queries. All right, so that's the plan. Let me stop right here. And starting from tomorrow, tomorrow after I finish my last class of this week, I will make homework assignments, quiz assignments, and a project assignment. So I will work on that part, assignment part, tomorrow after my last class of this week. All right, so that's it.